So when it comes to addition reactions to aldehydes and ketones, they can happen both under acidic and basic conditions. In addition, if a carbonyl is conjugated, then we have a second factor that we have to worry about. So let's start with acidic conditions, and we'll look at both possible things that could happen. So we're just going to talk about this reaction with H plus and a generic nucleophile. We're also going to see in these reactions that equilibrium is something we definitely have to account for, as all of these types of reactions are theoretically reversible. Now, under acidic conditions, we don't have nucleophiles that are as good. And that's because under acidic conditions, we can't have, things that are negatively charged. So in that kind of situation, if the nucleophile is weaker, then our only option is to make the electrophile better. And the way that we can make the electrophile better here is through acid. Lone pair on the carbonyl can attack the acid. And so if you see a reaction that's some sort of addition to a carbonyl and it's under acidic conditions, it's usually going to be a pretty safe bet that the first step in that reaction is protonation of the carbonyl. That makes it more reactive. From here, the nucleophile can do attack, electrons push up onto oxygen, and we get this alcohol and the nucleophile. This product here is known as the 1,2 addition. But note that this is reversible. And under certain conditions, if we revert back to the protonated carbonyl, the nucleophile can instead attack at the double bond. Pi electrons move up and again make the alcohol. Which gives us a very different intermediate. Looks like that. And then from here, this undergoes a process known as tautomerization. And you may recall from the section on alkynes, this group here, known as an enol, is under acidic or basic conditions is able to very easily undergo this conversion back to the carbonyl. And so you can see we have two very, very different products here. The first one, the 1,2 addition, where the nucleophile added directly to the carbonyl carbon. And the second one, which we refer to as the 1,4 addition, where the nucleophile added at the alkene. Now, does it make a difference if we're under basic conditions? Can we have both of these occur under basic conditions? And the answer is yes, we can have both of these reactions under basic conditions. The mechanisms are a little bit different, but it's mainly just a difference in the order of the steps. So we're just going to use generic nucleophile here. And if this is going to be a 1,2, nucleophile directly attacks the carbonyl. And then that oxygen anion can pick up a proton to give us our product. Again, this is our 1,2 addition. And if you compare back to the 1,2 addition under acidic conditions, you'll notice it's actually the same two mechanistic steps. Nucleophile adds to the carbonyl, and oxygen picks up a proton. The only difference is that the order of those two steps is essentially reversed. But we can also get 1,4 addition. 1,4 addition happens through the nucleophile adding at the alkene. Electrons get pushed all the way up onto the oxygen. And then the carbonyl reforms. These pi electrons go and grab a hydrogen. From somewhere, typically the solvent. And again, we get the same 1,4 product that we saw under acidic conditions. So what determines if we get 1,2 or 1,4? The answer is the difference between 1,2 and 1,4 addition is all about what the nucleophile is. Because 1,2 has lower activation energy. And so because it has a lower activation energy, it will always occur first. So even in a situation where we get 1,4 as the product, 1,2 happens first. Now, if the nucleophile is a poor leaving group, and typically this is things like R- and H-, then 1,2 is not reversible. And if it's not reversible, then the 1,2 addition will be our final product. However, if the nucleophile can be a leaving group, and notice that wording is very specific. Doesn't mean it's a good leaving group, just means that it can be a leaving group. And so if it can be a leaving group, then the 1,2 addition will reverse, and the more stable 1,4 product will form. And so next, we'll start looking at some specific reactions and specific nucleophiles to see, what we can do with these reactions, as well as when we get 1,2 and when we get 1,4.